Today's lesson is 9.2, Similar Figures. Similar polygons have the following three characteristics. They need to be the same shape, but different sizes. Normally, one is small and one is much larger. The corresponding sides must grow or shrink by the same multiplier called the scale factor. What I multiply this side by to get this one, I must also multiply the top by to get the top of this one. Now, since this is a rectangle, what I do to this side is automatically what I would do to this side, and what I do to the top should automatically be what I do to the bottom. So it's okay not to check all four of them, but normally, if your shape is not a rectangle or a trapezoid or something like that, that you know the properties of, you would have to check all the sides. But they have to grow by the same one. If I multiply this by 2 to get this, then I have to multiply the top by 2 to get the top of this one. All right, and the corresponding angles are congruent. Notice my 90 degrees does not change. In any of the corners, it doesn't matter. It's going to stay 90 degrees. All right, so if we take a look at this in a Venn diagram, we can see that the corresponding sides are going to be congruent when I have congruent figures. The corresponding sides are going to be congruent. But when I have similar figures, when I'm talking about similarity, the sides are what we call proportional. This means that they're going to make a ratio. We're going to see that factor of A over B. In both of them, notice right here in the middle where they share it, the corresponding angles are congruent. Okay, so that means if I do have a congruent figure, if I have two congruent figures, they are automatically similar. But if I have two similar figures, they are not automatically congruent because similar says one's big, one's small. All right. Two polygons are said to be similar if and only if their vertices can be paired so that the corresponding angles are congruent. Let's go ahead and take a look at our, at just this shape right here. Make something. I'll make a quadrilateral. Doesn't have to be a rectangle. I'll make a little bit larger. Oops, no, let go. There we go. Now it says if I know that, oh, let me grab my blue. This angle and this angle are the same. That angle and that angle are the same. This one and this one. And then this one and this one. 2, 3, 4. There we go. Then they can be similar, but also that their corresponding sides are proportional. So let's go ahead and I'll draw two rectangles this time, or at least I'll do my best to. There we go. There's one small rectangle. Let's say that we know that the top is 4 and the side is 3. It could be any unit. It doesn't matter. And then let's draw just a little bit bigger of one. I know that the space is constricting, but let's say that this is 8 and this is 6. I can tell that 4 times 2 gives me 8, and that 3 times 2 gives me 6. So they are, I can make a ratio of that. If I were to take the two blue numbers, I can make a fraction that would reduce to the same as the two purple numbers. Okay, this is called a scale factor. This is the ratio of the length of two corresponding sides in my similar triangle. Up above, it would be my purple one. Let's say it is 8 over 4, which reduces to 2, and then 6 over 3, which reduces to 2. All right. We also have what is called a similarity statement. And this is a statement that basically just tells you that two shapes are similar. So here's the name of a triangle, ABC. This is the symbol for similar. It's just the wave part that we would see in the congruence symbol. Just the wave, no equal sign this time because we're not equal. D, E, F. Now, this statement is very important because it tells me which angles are equal. A is equal to D, B is equal to E, and C is equal to F because of their position, first, middle, last. Also, I can pair them up for the sides. A and B are going to pair up with D and E. B and C are going to pair up with E and F, and then of course AC is going to pair up with D and F. Now what I like to do is I actually like to mark the picture first with the angles because then I can pair it up with angle marks. I can simply see that this side here is going to correspond to this side here because I have 1 and I have 4. I have 1 and I have 4. This side is going to pair up with this side because we have 1 and 2, 1 and 2. And so that's how I like to do it. All right, so example number 1 of 2 today. They're asking, are the polygons similar? Are the polygons similar? Well, two things have to happen. Well, actually, three things have to happen. And the first couple should be visual. The first one is visual. Is one small and one big? Are they the same shape, but one is smaller and one is bigger? I would say yes. These look pretty much like they are the same shape, just this one happens to be a little bit smaller than this one. Now I'm going to look at the angles. I want to make sure that each angle in the small one pairs to an angle in the large one, or vice versa. It doesn't matter which one you do first. So I see a 90 degrees. I see a 90 degrees. I see 1, 2, 3. I see 1, 2, 3. I see 1, 2. I see 1, 2. I see 1. I see 1. They all pair up. Now we're going to look at the sides. And when we look at the sides, we actually have to make a fraction. So I'm going to grab my highlighters and I'm going to start highlighting the sides. And it doesn't matter where I start. I'm going to start right here between the 90 degrees and the 3 angle marks. So I'm going to find that same side and the other one. Now, if you do not have a highlighter, it's okay. What you could do is simply put a dot and a dot. They are not the same. You do not want to use a tick mark like we would for congruence because 9 and 12 are not equal numbers. So a dot just to say that, hey, these two are going to make a fraction. And now let's grab this one. It goes from the 3 to the 2. So you could dot, 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 dot if you don't have color. You could use your pencil for that. This one will pair with this one, and it appears I seem to be missing a number. Let me add that in there. My mistake. There we go. And likewise, you would just put 1, 2, 3, 1, 2, 3, because those two are going to make a number, are going to make a fraction. And now I just need one last color. Oh, it doesn't matter. There we go. Let's pick the green because the fourth sides are going to go together. Now you could have actually left that, and of course the unmarked sides would pair up. All right, let's go ahead and make our fraction. Now there's really no rhyme or reason as to how to make the fraction when you are comparing them to decide if they are similar. Now, when we do the scale factor, that's a different story. But for right now, we're just deciding, are they similar? So it doesn't matter how you make your fraction. I'm going to go ahead and make the fraction as to the smaller one over the larger one. That's how I'm going to do it. But that's just what I want to do. So I'm going to say 9 over 12, and I'm going to go ahead and reduce that. 9 over 12 reduces to 3 over 4. And I have to do this for all 4 fractions. So that was my purple one. Let me grab my marker. This was my purple one. Now I'm going to go ahead and I'm going to do the blue one. and I'm going to do 15 over 20. Once I have picked which fraction is going, or which shape is going to be my numerator, the top of my fraction, I cannot switch it. If I switch it, I'm going to end up with giving the wrong answer one way or the other. But this reduces to 3 over 4 as well. And now I can go ahead and continue on and do the purple, or sorry, the pink. Let's do the pink ones. 6 over 8, which is 3 over 4. And the last ones, we're going to do those green ones. So let me bring back my green. And we're going to do 12 over 16. And that reduces to 3 over 4 when I divide by 4. All right, so notice what I have. I have the same shape, different sizes. I have all angles being congruent, right? I checked them all. They're all congruent. And then all of my fractions, all of these numbers right here are exactly the same. I went ahead and checked them. I am going to go ahead and say that these two are similar. These two are similar. All right, so it says down here at the bottom, if they are similar, find the scale factor of DEFG to JKLM. Whenever you see this word scale factor of, this is important. Let me grab the green. The next part right here after it is going to tell you exactly how to um, set up your ratio. Okay, because the scale factor is a ratio. And when I see the word scale factor of, the next part is going to tell me how to set up my fraction, my ratio. This right here, the word 2, is my division symbol. Whatever is in front of it, whatever is first in front of the word 2, is going to be your numerator, the top of your fraction. So you're going to go to DEFG, this one right here, and you can pick a side, any side, because they all match up. Okay, so you just pick the side that you want. It doesn't matter. I like pink, so I'm going to pick 6. 2, the one after the word 2, is always going to be your denominator. So what is it? It's going to be 6 over 8, which reduces to 3 over 4, 3/4. This is my scale factor. All right, the last example, they want me to find the scale factor. And they tell me that, look at right here, they already are telling me that the triangles are similar. I don't have to play the guessing game. I know that angle R and angle X are exactly the same because they are in the same position. I know that S and Y are exactly the same as well. And then, of course, T and Z have to be because if you look at them, they are the 90 degrees. So I know, let me see, blue was my angles, that those two match and these two match. This is going to help me to which side goes with which side to make my proportions. So the bottom between the 1 and the 90 is going to go with the bottom between the 1 arc mark and the 90. Now I cannot use this side because notice in the smaller right triangle, the purple line is marked with the variable a. So I cannot use that to answer the scale factor question below. My hypotenuse here from the 1 arc mark to the 2 arc mark is going to go with this one right here. And of course, lastly, this one is going to go with this one. There we go. So I can pick either the blue or the green. I could use 45 or 27, and then I would just pick its corresponding one in the other triangle. When I do the scale factor, I have to pick one from here, one and its corresponding one from there. I cannot set my scale factor up using these two numbers. They're in the same triangle, it's just not going to work. So I have to either use the blues or I can use the greens. And remember, this sentence is going to help me as to which one goes where. So let's talk about that one more time. Let me grab my green. Find the scale factor of, remember, and now it's going to tell me how to find the scale factor. Find that word 2. I like to circle it. And this is your division bar. Here is your numerator. Here is your denominator. All right, so find something from X, Y, Z. That is the larger one. I'm going to go ahead and pick 30. I'm going to do the greens. It's a smaller number. It seems safer. Then I'm going to go to RST and I'm going to find the one that's green there, 27, and I'm going to go ahead and reduce this. If I divide both of them by 3, I get 10/9. Or you can go put them in decimals. All right, but there's one more question. It is asking me to find A. To find A, I'm simply going to set up a proportion. I'm going to set up a proportion because that's the whole point of the similarity. I'm going to set up a proportion. So here's how I like to set up my proportions, and I'm going to zoom out so that you can see my picture. I'm going to start with where the variable is. So I'm going to make a fraction, and I'm going to put the variable in the top. And I'm going to put the side that it matches in the bottom. So the purple to the purple. So I'm going to make a fraction with the purples. Then what I'm going to do is I'm going to just make the same type of fraction with the next one. So notice what I'm doing is the top is the small triangle and the bottom is the large triangle. So I have to do small triangle. I can pick 45 or I can pick 27. I'm going to do 45 this time. And then I have to put the large triangle in the denominator. Now, this is just one way that you can set them up. Oops, what did I do? What was that? And 45 goes with 50. So that's just one way that you could set it up. You could have also set it up A over either 45 or 27, and then done the same in the other one. So purple over blue, and then done purple over blue in the other triangle as well. Purple over green, purple over green. You just had to use the purple because that's where the variable A was. All right, let's zoom in so that we can solve this. Remember, whenever we have a proportion, we simply cross multiply. So for this one, we're going to do A times 50 equals 45 times 40. That, of course, gives us 50A is equal to 1,800 or 1,800. I'm going to simply divide that by 50 on both sides. And A equals 36.